So now we're going to do our next conversion problem. And this conversion problem has to do with how many minutes are in 1 and 1/7 of an hour. Now, I know that you know that 1 hour consists of 60 minutes. So we're going to write that down here. 1 hour equals 60 minutes. And so this is our conversion factor, number one. Number two, how are we going to set this up? We're going to set this up in exactly the same way as we did before. We want to know how many minutes are in 1 and 1/7 of an hour. So I'm going to let x be the number of minutes. We don't know yet, and that's why I'm labeling it as an x. Number of minutes in 1 and 1/7 of an hour. Okay. So now the proportion that we're going to set up is going to be as follows. First, our conversion factor. For reasons that'll become, well, I mean, it won't matter. So I'll do 1 on top, 60 on the bottom. So 1 is, as we know, our number of hours. 60 is our number of minutes. And then, since we put hours on the left, since we put hours on top, we're going to put hours on top on the right as well. So 1 and 1/7. Yes. This will be our hours. And since we put minutes on the bottom on the left, we're going to put minutes on the bottom on the right. So our x is our minutes. Okay. So this is our proportion. And again, and I know that sometimes I might sound like a broken record, but I want you to notice when I set up this conversion problem, I put hours on the top on the left, means I'm going to put hours on the top on the right. I put minutes on the bottom on the left, means I'm going to put minutes on the bottom on the right. And again, like I said before, if I had put minutes on the top on the left, I would have put minutes on the top on the right, and I would have put hours on the bottom on the left and hours on the bottom on the right. Yes. But this is our setup. Now, again, using our proportion solution technique, we know that we're going to do A times D equals to B times C. So 1 times x will just be x equals 60 times that. And by the way, one of the things I want you to notice here is that I always set it up in such a way that I put what I'm going to multiply and then I do the calculation separately. And the reason why I want to point that out to you is that whenever you're doing a problem like this, I want you to feel comfortable doing it on a separate sheet of paper. Don't feel like you have to clutter your paper with the calculations in all the places. You can do the logic flow of the calculation in one place and the calculations on another. That way it'll always stay organized and you'll always be able to review from what you're doing. Yes. And I'll admit that sometimes I get a little cluttered on the board, but on your notebook, don't let it get cluttered. Because, you have more room. Yes. So anyway, I'm going to shut up now and I'm going to perform this calculation. So I know that 60 times 1 and 1/7 is going to be the same as 60 times 7 times 1 is 7 plus 1 is 8. 8/7. And what is that? Well, that's going to be 60/1 because any number can be written as a fraction by putting it over 1 times 8/7. And now we remember when we multiply fractions, we multiply them across. So it's going to be 60 times 8, which I'm going to do over here. 60 times 8. 8 times 0 is 0. 8 times 6 is 48. So it's going to be 480 divided by 1 times 7 is 7. And so this is then what I'm going to do here is I'm going to divide out. I'm going to divide 7 into 48. 7 goes into 480. Because again, remember, I want to find out how many minutes there are. 7 goes into 4 It doesn't. 7 goes into 48. Aha. 7 times 6. Because 6 times 7 is 42. 8 minus 2 is 6. 4 minus 4 is 0. I bring down my 0. I ask myself, how many times does 7 go into 60? 8 times. Because 8 times 7 is 56. Now, 0 minus 6, I can't do that. But I can borrow from the 6 here. That becomes a 5. And this becomes a 10. 10 minus 6 is 4. 5 minus 5 is 0. So I can see, aha, 7 does not go into 4. There's nothing else that I could have brought on. So I'm left with, so 480 divided by 7 can be written as 68 and 4 over 7. Or, if I want to go with a decimal expansion, what I'm going to show you here is I'm going to change color. I'm going to put my decimal point. I'm going to put a 0. I'm going to bring that down. Then I ask myself, does 7 go into 40? Indeed it does. 5 times. 5 times 7 is 35. 40 minus 35 is 5. And you can see I can continue going this way. I recommend when you're practicing long division to always do it like that so that you can get a hang of it. So I'm going to put here, now here I'm going to put a squiggly equals because that means not equal anymore. It means almost equal. So nearly 68.5. Okay? Okay. So that means that to this original problem, it's 68.5, approximately 68.5 minutes are in 1 1/7 of an hour. Yes. And there you go. Ta-da!